We cannot hear you. Nabil, something wrong. Okay, so David, did you start work on the stuff which Mudassar actually? Yeah, David, can you hear me? David.
Yes, I'm going to start.
Yeah, so did you start something in the ZMAX?
Okay, can you see the presentation?
Yes, I can see.
Okay, this time I'm going to present the Chernik-Turner-Raman spectrometer on ANSI CMAX Optic Studio Student Edition.
Okay, so first thing before you start, actually, did you start? This is also kind of a tutorial, or did you do something by yourself?
It's a I try to do something by myself.
Ah, okay.
It's a tutorial paper of Mudasim.
Ah, okay, okay.
This is
Yes.
about Raman spectroscopy. Like you
Okay.
can see in the first slide, is for example, a green laser excites a molecule that then be bright can
Yeah.
produce three types of scattering. One is Rayleigh scattering, when
Mhm.
wavelength is equal of the wavelength of the scatter is equal to the wavelength of the laser. The other type is uh, scatter anti-stock.
Okay.
Uh, in the Raman, in this case, the wavelength of the scatter is less than the wavelength of the laser, and the other type of scattering is the stock Raman,
Mhm.
when wavelength of the scatter is greater or
Okay.
more big than the wavelength of the laser. This
Mhm.
is a typical setup of the Raman spectrometer with you have a laser and some optics that you get into the sample, and then the sample is captured by the spectrometer.
Mhm.
This is,
Mhm.
in this case, the Cerny-Turner spectrometer.
Yes.
And
Yes.
this spectrometer is very, is quite more, quite more elaborated. You have two curved lenses. One lens is going to focus your first light into planar waves to put into the diffraction grating.
Yeah.
Then this diffraction grating is going to put another plate that is going to focus to a CCD sensor. Okay. Entonces, the Cerny-Turner configuration is an optical layout commonly used in dispersive spectrometers, especially in the UV vis Raman spectroscopy. This configuration was developed by Marcel Cerny and Andreas Turner in 1930 and is especially valued for his high spectral resolution, flexibility, and ease of alignment. What is a Cerny-Turner configuration? It's an optical design based on the use of two concave mirrors and a diffraction grating, with the components arranged in ways that allows precise control over the dispersion and focuses of light. In this case, this configuration reduces the coma aberration. Main components: entrance source or entrance slit is the point where light enters the system in Raman spectroscopy. This is the scattered light from the sample. Collimating mirror M1 converts the divergent light from the transient slit into a parallel beam. Diffraction grading G disperse the collimated light into its spectral components according to the diffraction law. Focusing mirror M2 collects the dispersed beams and focuses them onto different position of the focal plane. Axis elite or detector D captures the dispersed light, usually with a CCD detector. And we have here the setup, the entrance slit, then the curved lens, and then into the diffraction grating, and we have some angles like theta and alpha, and then the another curved mirror, and then the exit slit. The exit slit is when usually you're going to have your CCD device, your couple charge device. And here for the relay, yeah, is equal to the entrance of the wavelength. And usually the Raman spectrometer have a 50 to 4,000 dispersion in centimeter to -1. And in this case, for the stocks, we have this change of wavelengths approximately. And for anti-stock, we have this range of change of the wavelength. Um, what is useful in Raman spectroscopy? Raman spectroscopy requires high resolution and spectral precision to detect a small frequency shift that is 50 to 4,000 centimeters to the -1. Relative to the laser excitation, the Cernik-Turner configuration meet these requirements. A specific advantage, high spectral resolution, capable of distinguish very closely spaced Raman shift, flexibility, easy to modify for different wavelengths and resolution settings. Laser line rejection can be combined with rejection filters such as notch or edge filters before the entrance slit. CCD compatibility allows simultaneous recorder or multiple wavelengths. And this is the design of Mudassir in his paper that is going to be simulated on CMAX, and they have a laser beam or 527 nanometers. It's going to focus in a sample, then the sample is going to disperse some wavelengths, and this wavelength is going to enter to the entrance slit. Then a collimated mirror is going to focus that light into the diffraction grating. The diffraction grating is going to disperse that light. And then another focusing mirror is going to put that lights into the CCD device. And this is another configuration more about to obtain the equation that is going to give me the diffraction grating settings or parameters that you are going to put in the CMAT software. There is a lot of mathematical setup for this case, and you can follow in the paper of Mudassir. And in this case, this table of the lens data editor in CMAX, you need to put is a source, a sample, a slit, a collimated mirror, a diffraction grating, a focusing mirror, and a CCD device with this radius of curvature and thickness and semi-diameter. Then I try to put that in the CMAX software, but we and also for in this case we are going to use the parametric mode, sorry, the sequential mode. Instead of use the ray tracing algorithm that is usually used, we are going to try to use the physical optical algorithm that first described, and this is going to be the parameters of the wavelength, the laser wavelength 427 nanometers, the observed Raman spectra in the range from 530 nanometers to 630 nanometers. The entrance pupil diameter 0.16, the grating constant 0.100 lines by micrometer, the CCD pixel 1024 by 1024, the slit width 30 micrometers, the size of the pixel 5 micrometers, radius 1, minus 10 millimeters, the radius 2, minus 10 millimeters, x1, 3 millimeters, x2, 3 millimeters, x3, 4.5 millimeters. But when we try to modify the diffraction gradient, because I have the student version did not work. I not allowed to do that modification. And this way I cannot simulate the another stuff like the beam spot or the intensity distribution of various wavelength or the MTF function, the modulation transfer function, and the relative illumination into the surface of the beam spot on the detector. For the next case, I'm going to ask for help for Budasir. For maybe I get another version of the CMAS Optic Studio that is not the student version because I cannot simulate that.
Yeah. So
Uh,
yeah. So David, actually, probably Nabil, are you there? Nabil,
Yes, sir.
can you hear me?
Yes, sir. Yes, sir. Yes, sir.
No, I think there are two devices now. Echo is coming.
Is it still there?
Yes, echo is coming. So David, I mean, probably they have the Mudassar and the Nabil, they are using the cracked version of ZMax. So probably they can help you to install this kind of thing on your computer. But you can also try to find a crack if you have some other resources or something like this.
okay, I want to try to
Yeah,
find.
yeah, try to find. Otherwise, I mean, they definitely they have the cracked version, but it's older. It's I think around 2013, more than 10-year old.
Yeah, okay, no problem. But
Yeah, yeah, they can.
with that version, they can do that amazing simulation of the
Yes, yes,
Cerny-Turner device
yes,
for
yes, yes,
Raman spectroscopy.
yes. Yeah. So what I am saying that maybe if you try, you can find the latest crack from somewhere. So, but anyway, today Mudassar is absent probably, so I will ask him. Nabil can also probably, but his net is always having a problem. So I mean, so you couldn't go through further. I mean, David.
Okay,
Yeah,
okay.
you couldn't go through further. How about the LIDAR? How about LIDAR?
The LIDAR is the same case. We have the files because the tutorial give me the simulation file, but I cannot open. Only for the first tutorial, there are 3 tutorial.
Okay.
And when we move to the non-sequential mode, the files cannot be open because I don't have that feature in my software
Okay. Okay.
because the student version.
Okay. 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 So Nabil, I think you have always problem. I don't know how to communicate with you.
I think it's fine now.
Yes. So can you show your face?
Yes, sir.
Yeah. Thank you very much. Yeah. Nabil, I think you have to prepare 30 minutes before because you always have problem.
I don't know, sir. It's the problem, but I tried.
Mhm.
I won't go into things, but I tried.
Okay. So the thing is that how we can help David regarding this software, the ZMax.
CMAX,
Hmm.
uh, we can start with some basics.
No, no, no. He's
Some basic.
no, no, no. How to give him that cracked version and he to install it.
I have the file. I guess it's 13.
Mhm.
Uh, I can share it. You can check if it works or not,
But the
or he can
installation is
down.
because cracked one. It's not bit tricky or it's easy.
No, No, sir, it's not tricky. It's easy. You just have to copy and paste file in the master folder.
Okay. Uh-huh. Uh-huh.
Yes, sir.
Okay, so you can share and you can send the share link, or you can do it through the web page, my web page, which you can upload from there. Okay.
I think I have already uploaded it on my OneDrive.
No,
So,
that is okay, but it has to be through through my web page is much better through the
okay,
virtual.
sir.
Yeah. So it will be password protected and he can download from there. When you are ready
Okay,
to
sir.
upload, let me know. Actually, I will give you the access. And then from there he can download.
Okay, sir.
Okay. And
Another thing that I in the previous lecture, and they have the looking amplifier, the simulation. I see that I'm going to work also in that. That they didn't know the resistor values, but in this case, I taking a course on operational amplifier, and they say that they don't give you the resistor values because you can play with that values to give the better response to you.
mhm.
I can try to do the paper setups in the multisims
Okay.
and then share with the other student that is working with the looking amplifier paper.
Okay. 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 Sure. He's here actually. Guzanfar, you are there? Guzanfar. Okay, we come back.
Yes, sir. Can you hear?
Yes, we can hear you actually. Show us your face. Okay. So thank you very much for attending the meeting because I was expecting that there will be more absences here today. So David is saying about the
Sir,
lock-in amplifier. Example, David is saying about the lock-in amplifier stuff. So David, can you please say again?
Okay, I'm going to try to do the setups in the your paper, but the last meeting you say that there is not a resistor and capacitor values, but you need to play with that values to and then to give the requirements, for example, for amplification or for another. Maybe the author don't give you the values because you need to play with that, but the configuration is the same.
Yeah, but he did already actually. He put some
yes,
values. Yeah, he did
yes,
something.
sir. The amplification board which is required according to paper.
Mhm. But David, you can also
See all
share.
the values capacitor and
Yeah, David, you can also share. We can see. I mean, okay. So I mean, Gazanfar, I will come back to you later. I think your net is having a problem today, isn't it? Your net is okay.
maybe, sir.
Yes, but anyway, I will come back to you. First, I finish with Nabil. So Nabil, can you please update regarding your stuff?
Because actually, we have to do the lens focusing system or second harmonic generation system.
I think both. I said you. I mean, you have. I mean, you have been doing this thing for last couple of months. This focusing or something like this.
Yes, sir.
So what I asked you at that time to first you make it on the paper with the hand and calculate the focal points. Okay, and then you can simulate. I think much easier in this way. Use one lens, two lens, three lens, something like this.
Yes, sir. Actually, I think the problem is with my what you can say uh, software, ZMX software. Actually, I try to increase the rays, as Mudassir said in the last meeting, that all the rays are going through the center part, but
Mhm.
not the edges part. So, and plus the effective length is not okay.
Mhm.
So, first I need to do their things, why they are not going through the edges and only through the centers. Then we can try to simulate it and check the results if they are okay or not.
I think you have to do it systematically, the build this thing. It's the same issue when the first time you simulated.
Actually, then we optimized it, and that was the last one which I did was which actually the last which I presented was the system optimized by Mudassir himself, and I made changes according to that. I don't know. I will go through.
But
That was optimized by Mudassir.
really, but why did you mention this thing in the last meeting?
I don't know.
You feel under pressure when he comes?
No.
Mhm. So, I mean, if you knew this thing, you could have mentioned in the last meeting, because you know that it's really, I think he has some kind of other kind of tension. That is why he gets angry and hyper very easily. So, yeah. But important thing what I want to mention actually, this thing will go on. You have to do it, okay? Uh,
Yes, sir.
but your thesis stuff, which you have already done,
Yes,
I
sir.
want you to do this one. I mean, to enhance it a bit, okay? To have more results, okay?
Uh,
And important thing, just a minute, listen to me first. Important thing is the harmonic separator in that, okay?
sir.
The most
Actually,
important.
that is important.
Yes. And to optimize this one, and if we can have some more results, well, I don't know whether it's sequential or non-sequential you have done already.
It was non-sequential mode.
Okay, so if you can do it in sequential mode, so if we can have more results. So I already made a paper, I mean, a kind of half of the paper last time. So probably if we can enhance, we can add some more results. So probably we can make your third paper. Okay.
Actually, the thing is, the only thing we are having problem with is second harmonic generation unit, which was, I can say, sort out it. But the issue is with harmonic separator.
Mhm.
It's not built in. We have to make it using some lens or something, some glass, and we have to actually design its physics in Zmax, how it works. Beam splitter is an easy thing.
Mhm.
I added beam splitter in my last setup.
Okay.
So, which was, you can say, not actual replica, but kind of uh, it was kind of visualization of my setup.
Mhm.
So we need to make beam splitter in Zmax. Then we can move further with more results and some.
Okay, so you can stop the other one. Just concentrate on this one. Finish this one.
Okay.
Okay, stop that one at the moment, the focusing. Okay, and concentrate on this one, because it's 50% is done already. Okay. Okay, so 50% you need to add something. Okay.
Yes.
And we can publish. It's good. I mean, if you can have 3 papers from your thesis. Okay.
Yes, sir.
And
Okay.
but you have to do it, and you have to tolerate the angriness of Mudassar time by time.
No,
Okay.
I can tolerate. I have
Yeah.
lived with him.
Yes.
We shared the same room. I can tolerate.
No, at that time he was different. Okay, he was like this somehow, but now he's extremely different now. Okay. तो वो कहते हैं ना, उर्दू एक्चुअली, कि हुस्न हो तो नज़ाकत आ ही जाती है. So it's something like, sorry David, so this is something like this. And but anyway, you have to do this one, so probably we can also, I was
Okay.
requesting you about the Oslo.
Okay, sir. I'll try to do Oslo also. Actually, Oslo has limited stuff to learn from the internet.
Mhm.
So we have to go through some articles or its, what you can say, tutorial book,
Mhm.
and then we can have
Mhm. Mhm. Mhm.
some better understanding of Oslo.
And you were saying that you will discuss with Mudassar something to have a
Second
kind.
harmonic generator, Zmax part.
Yes. something like this. So
Yeah.
probably. Anyway, I mean, it's much better if you can in the next meeting, if you can have some results from your this harmonic separator stuff, so we can discuss more. Okay.
Okay, sir.
Okay.
Okay, sir.
Okay, Zanfar, now your turn.
Yes, sir.
So, did you, I mean, go through or not yet? Anything? I'm just in general, I'm asking, like casual way.
Sir, I read the paper,
Mhm.
not fully, but almost half of the paper. The basic things which I already learned in your class in my MS. So I totally understand these things and little bit working on the basics of the leather.
Mhm.
So so far so good, not facing much any hurdles from the paper. So I understand the things which are uh, in the present in the article, which are talking about the sapphire laser. So I study the components and try to understand these things.
Mhm. And what else? I mean,
Also,
yes.
Yes, from last week, uh, all the group members are talking about the Oslo and these stuff. So I started the learning, start basic from the geo optics, ray optics, so that I can understand the things which are Mudassir and Nabil presenting in this meeting. So
Okay, so it's a good.
almost I
Mhm.
yes.
It's a good, but
So
I want you to keep you on the other side, and they are not on that side. Okay, I want you to keep on the this ultra fast side. They are not. They are on the pure optics side at the moment. Okay. Okay, it's good to learn a little bit, but I want to keep you on the other side. So that is why I give you that one to read, and then we do something else as well. Yes.
yes,
So that you have to
inshallah, sir,
understand.
yes, inshallah, next week I will complete the article, and if I uh, face some problem, we will discuss.
And how about the, I mean, status of your computer now?
Sir,
Same?
today I bought the laptop.
Ah, okay,
No,
okay.
no, I bought the laptop.
Ah, okay, okay.
But yes, I diagnosing it and running the program. If it's work, then I have the laptop.
Ah, okay, that's good. Congratulations.
Thank
So,
you.
yeah. So you get back to your track again. It's good actually. And second thing, your article. Your article is, you cannot say yet is accepted, okay? They give you a chance to rebuttal, to argue with two people who rejected, okay? So
Okay.
we can reply, we can give a response to their comment, okay? And if they are stubborn mind, I mean, if they are stubborn, they may not change. They will say, okay, it's rejected. But some are, I mean, may have a good nature. They can change, okay? But if they stays on the status of rejection, then it will not be accepted, okay? But we will try probably, okay? So
Okay.
this is a routine work. I mean, whenever you publish something in the journal, this is a routine kind of things. Okay. Sometimes you get very soft people, sometimes you get very rude kind of people. Okay. So both times you got some rude people actually until now. One is okay, but the others are always rude. So we'll see what we can do. But you can, I mean, you can keep in touch with Mudassar regarding the comments of the first reviewer. Okay. And you can improve that thing even if it is not accepted in the same article. So we can try another one a little bit improved way, okay? And the second thing is that to keep in touch with the Mudassar regarding your lock-in amplifier stuff,
So
okay?
now I get the laptop, so I will be touching
You can also
with
do
that.
by, yeah, you can also do by yourself now. You have a computer. Yes?
Yes.
Yes, so you can
Yes.
rather to depend on anyone else, you can do it. Okay. And to finish it, I mean, you need put some graphs and something like this, which you were saying last time that the origin it possible or you already have done.
Yes.
Yes. So yeah, this is good actually. So you can do it and for your second article, and probably that would be a good thing if you complete. It's I think 50-60% you have done it, so you know what you are doing and what you have done. Okay. So rather to depend on the Mudassar, if he does, it's okay, but he is a very busy person, angry and busy person. So probably, I mean, if you can continue by yourself, you can. Okay. So, and other thing which I want to mention today that about the course which I am offering, the ultra fast laser courses. So it's around, I think around 19 or 20 people. They, I mean, fill up the form which I asked them to do it. And more definitely from Pakistan, but there are some from the other countries as well, like from South America, Mexico. I think 3 students, 2 from Mexico, 1 from Peru probably, and there are 1 from I think 1 from India, from China, from Moscow, something like this. So hopefully that will go smoothly, but there will be one issue of timing. Like Mexico timing is far, it's around 9 to 10 hours difference. So anyway, I mean, we have to manage these kind of things. So Zanfer, especially this course will also, I mean, very helpful for you
Yes, sir.
to understand this thing and for our expert.
Maybe we can help with the recorder of the lecture. In this case, if you give the course some hour and then one person cannot assist, can see the lecture and do the assignments or tasks of that
We'll
lecture.
see. We will see. First, I will discuss with them. I mean, the timing. I mean, I want all the people to be online and to interact with them. Actually, it's much better than the offline or recorded one. So that course, I think, I hope it will be, I mean, helpful for some of the people who are working on this kind of stuff. But some of the people who registered for this course, their background is not at all lasers actually, but they want to learn laser. Okay, so ultra fast, I mean, the course is like this. You have to start from the pulse lasers. Okay, so you are not supposed to discuss the basics of the lasers. So that would be a difficult task somehow, how to manage some of the students who are not having a background, the lasers. But anyway, I mean, I will see uh, how it can be done because I think around 40 to 50% students are really beginners in the lasers. And this course was specifically, actually, I was thinking for pulse laser, uh, dedicated to the pulse lasers. But anyway, I will see how I will manage. And in the future, I will also offer some more courses as well and some workshops as well. That will come. I mean, we'll see later what kind of workshop can be arranged or something like this. So, I mean, Fiasab, if you want to say anything, I can see that you are online now.
Hello, sir.
Yes.
I think it's a good evening over there. Hello, David. Good morning to you and Zanfar and Nabil. Almost good evening there also. Sir, thank you. Basically, what I was like thinking last time I shared some files. So, like the Mudassar, if Nabil and Zanfar, like they are up with these things, we can discuss the further steps because the what the
Yeah.
main purpose was to first simulate the laser diode beam and then pump it to the crystal. Okay, then we find the energy density for this pumping system, depending upon the shaping of the system, and then the output beam for the pumping of the laser crystal. Upon that, we find the energy density, and then we can find the thermal lensing in it. Okay. After this, just let me complete my scenario, what we want to do. So after this, we will do the thermal analysis for the InnoSlab lasers, which I have done. I have the consoles files for that one. So if we can, because like previous people also have done this thing, so we just want to formulate this into a type of a paper which already have been almost 99% completed. But if that could be updated with the newer versions of more refined pumping systems, integrated with the ANSYS or the console thermal analysis, then this paper could be the good to go. Okay. So my question, my point was like if the Nabil or the Zanfar or Mudassar has done something with that initial simulation, we can, or if they have any questions regarding
No,
that thing, we
let
can
me,
discuss
yeah,
this.
let me explain you first. Nabil and Ghazanfar, they are not involved as such now. So only Mudassar is involved. Okay.
Okay.
And Mudassar, he has done something, as he mentioned to me, but in this meeting, he's not available.
That's fine. That's fine.
So this is what I mentioned in the WhatsApp. This discussion will be fruitful if Mudassar is available. So Mudassar is not available at the moment, and he was saying he has done something. So
Okay.
probably in the next meeting he will be
Because
available.
Mudassar was like saying he will try to do it in sequential mode. Okay. So that will be something that's like a bit new for me. Mostly non-sequential mode, but I have done this all files, even the ZMAX files I shared with them was done the non-sequential, and most likely the lasers things are this shaping system are always done in most of papers. Even like I will share the shaping system papers as well for the laser diode with Mudassar. So because if in that sense the parameters can exactly be defined, then we could have exact output what we want to have it. So like with more purified results, then we can like code that result for our paper in a better way. So okay, if Mudassar is not available today, no problem. We can like not in hurry. It's a
Yeah, I mean,
upon him. And
yeah,
if he has any questions, like
yeah, I mean,
later on, we
Fiasa,
can talk
maybe,
him about.
yeah, Fiasa, maybe Nabil, if do you want to add something here? You were in the last meeting, Nabil, are there? Nabil?
Yes, sir. Yes, sir.
Yeah, you were here in the last meeting, isn't it?
Yes, sir. I was there.
So do you want to add something what Dr. Fiaz is saying? Did you go through that one?
If his ZMAX file?
Yeah.
No, I didn't check it. I didn't check it. I don't remember. I checked it.
Okay, okay. So only Mudassar is a person who is doing this work, Fiasa, and so probably he may update. I mean, in the WhatsApp group as well, and what he has done. But definitely, surely he has done something, and
that will be good to know.
yeah, and he will be doing. He will be contributing in this one because I know him very well. So I hope in the next meeting he may present something regarding this.
Sure, sure. Like even Nabil, if you need to like know these things about this ZMAX file as well, I can explain. Because I have shared this PPT as well with an example how to simulate a laser diode into non-sequential mode. And but like there are some confusing elements which need to be sure about that. Okay, so that what I was looking for. So second thing is like as you was like saying, you are like preparing a course for ultra fast lasers, or only like the pulse laser. Is it right?
Yeah, I mean, basically, ultra fast laser is a pulse laser. So
No, I mean like when you start from the or directly from the pulse laser, or you will start from the basics things?
No,
Like
this
I was not.
no, this is what I was. I didn't decide yet because I was looking the profiles of the people who enrolled in it. So some of the people, they don't have a background, so I'm not sure. I mean, from where I will start yet.
Okay. Anyhow, like in that case, if like you need any assistance from my side, like in that courses, like let me know. I will be
Sure.
there on you.
Sure, no problem. And so anybody else, I mean, wants to add anything, because today is short meeting, and because Mudassar is not here. So if you people, David, do you want to add something?
Not from my side. Also, it's another program that I'm going to try to find something. Maybe this is a more less cost program. I think that the few listens cost about uh, $4,000. Is more cheaper than the ANSYS CMAX software. And yeah, also you can try for 5 um, um 45 days. Okay. They have several tests, and you can also download all the systems. In some case, they give you the files. In other not, but they share the capabilities of the software. The name of the software is Quoda.
Yeah, Quad.
Yeah.
Yeah, I mean, you can try, but see, I mean, if you can find something from this course, sorry, from this course, yeah, I'm saying like on this software. But I prefer my student to stick with the one thing at the moment, so
Okay.
that it's much easier to follow up. But you can explore this software. And you can also try, David, that the Python.
Okay.
Yeah. I don't know about the Python stuff much, but you can also see the integration of the Python with the Zmax and how it can be done.
Okay.
Yeah.
And the other point is this book is about cloud, really?
Yes, it's a famous book.
This is about 20 years giving femtosecond laser course, in this case in France. And
Yes.
they need to give that lecture in 1 week to scientists and engineers, and they all the lecture have condensed in this book. Maybe then
Yeah, no,
can.
I know this book. But this book is difficult for some of the students. I want to go from the easy. But
Okay.
you can read. I mean, this book is. But
That,
I follow this
David,
book.
do share this book in the group, please.
Not yet. Okay.
No, I'm just asking, like later on, share this PDF of this book in the WhatsApp.
Okay.
Okay, so thank you, David. So Nabil, do you want to add something? Nabil,
Yes, sir.
do you want to say something before to conclude
About
the
the later
meeting?
course?
No, before to conclude the meeting.
No, sir.
So next week, I mean, you have to discuss about the results of your stuff. Okay, Nabil.
Okay, sir. I'll make a presentation what I actually have and what I want to try to do.
Yeah, I mean,
some
not
result.
very long presentation, just a 2, 3, 4 slides, so easier to discuss the thing. Okay.
Okay, sir.
Okay, and Guzanfar.
Yes, sir.
So, do you want to add anything, or you will be presenting in the next meeting something, or what is your plan now?
Sir, one thing is due the presentation of my thesis. I prepared the PPT, but unfortunately, my laptop is not in this world. So maybe I will make a presentation for my thesis and present this next week.
Yeah, okay, thesis, but how about this ultra fast? When will you present?
Sir, maybe next week.
Mhm. Okay, so your MS thesis, if you want to prepare the presentation, don't make it very long, okay? Brief and precise. Okay, Zanfar?
Okay, sir.
Okay, okay. And also,
I should move long or short?
short.
Okay.
And
Precise.
yeah, and also try to do something with that lock-in amplifier stuff. So probably if you need to discuss in the meeting something, may be helpful.
So,
Okay. So Fiasab, do you want to add, or you have already said whatever you want?
Thank you so much, sir. Sir, I see your post on LinkedIn where you like talk about your ZMAX book. I recommend you please share this book because it's free on Amazon, but I didn't try
No,
to
no, no.
find it
It's a free for a few days. They have a sale of for a few days. Now it's not free anymore.
Okay.
Mm.
And that's why like I didn't thought that it was
But it's very
at
cheap.
that time too.
It's very cheap. It's I think it's $4 or $5 only.
Okay.
Yeah. It's very cheap.
So, because I didn't get a chance to read it, so I was like wondering if like it
Mhm.
has something, the content of this book is available or not.
Mhm. No, actually, you can go to the Amazon and you can purchase it. It's cheap actually. It's not very expensive. And they have their rights actually. We cannot share in this way.
Okay, definitely.
Yeah.
No, if
Yeah.
it's not free, definitely it's
Yeah.
copyrighted.
Yes.
It couldn't be shared.
Yeah.
But that's fine. That's fine.
So okay then. Yeah. So
Okay then. Yeah. Thank you.
we conclude our meeting and we'll see you in the next week. Okay.
Sure.
Okay.
Okay.
Thank you. Thank you very
so
much, all of you.
Thank you. Thank you.
thank you very much.
Sure.